All right, class. In this lesson, we are going to learn to write and solve absolute value equations as well as absolute value inequalities. So let's go ahead and get started. Here's an example where we need to determine the value of x when 7 is equal to absolute value of x plus 2. Now, before we solve this problem, we need to understand what this absolute value of x means. Okay, so what you'll notice is this x has these two parallel lines next to it. And what that basically means is when the value of x, whatever the value of x is, the result of that is going to be a positive number. So for example, the absolute value of 4 is equal to 4, and the absolute value of negative 4 is also 4. Okay, so basically what we're saying is anything inside the absolute value, you're going to calculate and get a final result. If that number comes out positive, then obviously the answer is positive. And if that number comes out negative, the result will be positive. Okay, so another example is, let's say that we have the value of x in here. That value is going to be x. If the value inside the absolute value sign is negative x, then the result will be a positive x. Okay? All right, so hopefully that helps you to understand or provide some context into what absolute value means. So let's go ahead and work out this problem. We have 7 is equal to absolute value of x plus 2. And so the way we're going to work this out is first subtract 2 from both sides, okay, like we would normally do in any kind of algebra when we're solving for a variable. And this comes out to 5, and that is equal to the absolute value of x. Okay, so given what I just shared with you regarding absolute value sign, what this tells me is that x is going to equal 5, or x can also equal negative 5. Okay, so when we're talking about an absolute value equation in this example, you're going to have two answers. Okay, so let's move on to another example. What is the value of x in absolute value 2x minus 3 equals 1? Okay, so what we're going to do is split this equation into two different equations. Okay, so the first is we're going to write it without the absolute value sign. 2x minus 3 is equal to 1. And then the other set is going to be 2x minus 3, the entire quantity, and we're going to negate that, okay, because the opposite of whatever value is inside the absolute value sign will also be true. Okay, and we're going to set that equal to 1. So now we've got two equations, and we can go ahead and solve for x in both of those. So on the left side, we are going to add 3 to both sides. And when we do, we get 2x is equal to 4. Okay, and then to isolate x, we're going to divide both sides by 2. And we'll get x is equal to 2. So that is our first answer. And now on the right side, we have another equation. Here we have a negative here. So we need to resolve that first, and we can do that by dividing both sides by negative 1. And when we do, we get 2x minus 3 equals negative 1. Okay, now we're going to add 3 to both sides. And when we do, we get, oops, sorry about that. We get 2x is equal to 2, and then dividing both sides by 2 so that we can isolate x, we get x is equal to 1. Okay, so we have both x equals 2 and x equal 1. Okay, so both are solutions to this absolute value equation. Okay, let's move on to a third example. Okay, here we are asked to determine the value of x in this equation 3 times the absolute value of x plus 6 plus 8 is equal to 5. Okay, so the first thing we want to do is move the 8 from the left side of the equation to the right. And we do that by subtracting 8 on both sides. And when we do, we're left with 3 times the absolute value of x plus 6 is equal to negative 3. Okay, notice that in this example, we didn't split this equation up into 2 different parts yet. The reason that we don't do that is because we want to isolate this absolute value of x plus 6 and make sure it's all by itself before we split the equation up. Okay, so then the next step is to divide both sides by 3, okay? And that'll help us to isolate the absolute value of x plus 6. And when we do that, we're left with x plus 6 is equal to negative 1, okay? So at this point, we could separate this into 2 different equations like we did in the previous example. However, we need to take a look at what is going on in this equation. Now, what do I mean by that? Think about where we are in this equation. We have an absolute value of x plus 6, okay? So hold that thought for a second. We have that absolute value, and that is equal to negative 1, okay? Now, do you notice something unusual about this? Again, absolute value of x plus 6, okay, is equal to negative 1. So my question is that possible? I explained earlier, before we started the examples, that when we have this absolute value sign, this tells us that whatever we solve inside the absolute value sign, the result is going to be positive. That is the nature of this absolute value sign. So no matter what you do in here, the net result should be positive. Okay? Now, given that understanding, is it possible for an absolute value of x plus 6 to equal negative 1? So in other words, if we said that whatever we resolve here is going to be positive on this side, then is it possible to make it equal to a negative number? And the answer is no. Okay? No matter what we do on the left side of the equation, as long as we have these absolute value signs, there is no way for this answer to come out negative. And so the result here is going to be does not exist. Okay? There is no value of x that we can enter here such that when we take the absolute value of the result, it's going to come out to negative 1. Okay? So there's no answer here. Okay, so these 3 examples were all about equalities, right? So we worked with the equal sign. So now we're going to move on to an example that involves an inequality. Okay, so here is an absolute value inequality, and here's what we have for this example. Okay, we have the absolute value of x is less than 3. Okay, absolute value of x is less than 3. So if we were to split this up, okay, we would say that x, give us some more space here, x is going to be less than 3, okay, and x is going to be, well, let's see here. Before we go through that split, let me step back and let's just kind of walk through this mentally, okay? So if we have a value of x that's less than 3, we would say that 2 is less than 3, right? 1 is less than 3, 0 is less than 3. Okay, so we know that our solution is somewhere in here. Now let's go to the negative side. Is the absolute of negative 1 less than 3? Well, if we take the absolute value of negative 1, that comes out to 1, and so 1 is less than 3. Okay, so that is a solution. If we enter the value of negative 2 for x, then the absolute value of negative 2 becomes positive 2, and 2 is less than 3. Okay. Now if we use negative 3 and we put that in for x, the absolute value of negative 3 becomes a positive 3, and 3 is not less than 3. Okay, so we know therefore that our solution is going to be between negative 3 and 3. So when we graph this on the number line, we're going to place an open circle on negative 3, okay, because we have a less than sign here. There's no equal sign below, so that means it does not include negative 3. And the same thing with 3. We're going to put an open circle as well because there's no equal sign under the inequality. Okay, so then our solution is between negative 3 and 3. Okay, so now going back to the equation that I was going to split up, I'm going to work on the right side here so we've got a little more room. Okay, so normally when we split this up, we're going to say that x is less than 3, okay, or negative x is like less than 3, okay, because we need to negate this, and so x is less than 3 has already been graphed, so it's going in this direction. This is less than 3, and then we have negative x is less than 3, and what we need to do is resolve this negative, and we do that by dividing both sides by negative 1. Okay, that comes out to a positive x. Now when we divide or multiply by a negative number, our inequality sign has to change. So instead of less than, it is now greater than, and the result on the right side will be negative 3. Okay, so now you'll see that our x is also greater than negative 3, and so we drew a line to the right of it, and so what we have here is an AND condition for this compound inequality. Okay, and this is compound because we have two different inequalities here. Okay, and in order for this to be true, both this inequality and this inequality has to be satisfied. Okay, let's move on to this other example. Okay, so here we have x is greater than 3. Okay, now we're going to use the approach of splitting the equation up first this time. So we have, I'm going to just rewrite the example. X is greater than 3, so that means this is going to be x is greater than 3. Okay, and then the opposite will also be true. The left inequality is already solved, but we need to resolve this because of this negative number. And to do that, we divide both sides by negative 1. And when we do, we get x is, now again, because we're dividing by a negative number, we need to change the inequality sign. So instead of greater than, it's now going to be less than, and I forgot the negative sign here. This will become less than negative 3. Okay, so let's go ahead and graph this on the number line. X is greater than 3. Because we have this greater than sign, we're going to put an open circle on 3. Okay, and greater than means it's to the right. So every value to the right will be greater than 3. And then here we have x is less than negative 3. We have this less than sign. So we're going to put an open circle on negative 3. And we're going to draw an arrow to the left, because anything less than or to the left of -3 is going to be less than -3. Okay, so now this scenario is a little bit different than the previous example in that we have arrows pointing in the opposite directions. Okay, so when we have this type of compound inequality, we call this an OR condition. Okay, it's an OR because you can have an x less than -3 or an x greater than 3 for this absolute value inequality to be satisfied. Okay, both conditions don't have to exist. As long as one is true, then this absolute value inequality is true. Okay, hopefully that made sense. If any of this was not clear, I recommend that you go back to the beginning of the recording and listen to this again. Thank you.